Okay, so now we're going to continue back where we left off at on this second video, and then we'll be done for the videos of the sessions. So I'm going to go back from my current slide. Alright, so the problem tells me use log base 6 of 8, right? Log base 6 of 8 is approximately 1.1606. And log base 6 of 32 equals 1.9343, or approximately 1.9343. Okay, now my job is to find out log base 6 of 4. I want to know what that is. So what do you think the first thing is that we're going to do to find that out? If we have to divide our numbers, what do you think we do on this one, sir?
If we have to divide the numbers.
Okay, we divide the numbers, but what's peculiar about this particular problem? Look at that log base 6 of 8 and log base 6 of 32.
They all have log base 6.
Absolutely true. Now think a little deeper and say, what is 32 divided by 8 though?
4.
What are we looking for?
Oh, a 4?
Log base 6 of 4, right? So what if we took these two here and did log base 6 of 32 divided by 8, right? And did and did 32 divided by 8 to get our actual number. We'll be in good shape, right? So let's check that out. Log base 6 of 4 is going to equal log base 6 of 32 divided by 8. Alright, now we put 32 divided by 8 in parentheses because we already know that it equals 4. Right? It's point blank. So we replace 4 with the quotient 32 over 8. Now, log base 32, base 6 32 minus log base 6 of 8. I already have the two numbers, don't I? This right here goes here. This right here goes over here. I plug them in. So log base 6 of 32 is what?
632.
Just tell me, it's right here.
Oh, 1.9343.
All right, 1.9343 minus log base 6 of 8, which is
1.1606.
all right, 1.1606. Take your calculator for me, please, and subtract these two, and then tell me what the answer is, if you would, please, sir.
Yeah, 0.7737.
All right, 0.7737. This is my log based on my approximations. All right. So you need to write some things down, or any of you guys out there need to write some of these things down. I'll give you a second to do that. Once again, I will describe to you what I did. I took the base property of the quotient property of logs, log base b of m over n. When we divide, we subtract. So in this case here, we took log base 6 of 8, which is approximately 1.1606. The log base 6 of 32, which is approximately 1.9343. And then I'm looking for log base 6 of 4. Well, we automatically caught on to the fact that 32 divided by 8 is 4. And that brought us here to get our answer. So we subtracted the two together, got this, and we got our 0.7737. Okay? Any questions on that so far? Pretty simple, right? Not too bad quite yet. Does get a little bit more complicated as we go, though. So, can't get too comfortable on it quite yet. All right, what about that one? Log base 4. Matter of fact, you might be able to just tell me what to do here. Log base 5 of 4. And I'll write the problem for any viewers out there, just in case. Can I erase this, sir?
Yeah.
All right. So I'm going to erase this right here. And I'm going to get this problem, which is log base 5 of 4. Is approximately 0.8614. And then log base 5 of 32 was approximately 2.1534. Alright. Now, I want to know log base 5 of 8. Question mark. Alright, Scott, how do I figure this out? What is the easiest way to go about doing this problem that you see here?
Just like we did the last one.
Okay.
32 divided by 4 equals 8.
Boom. Okay, 32 divided by 4 equals 8, right?
Mm-hmm.
So all we got to do is take what's already known to us here, right? And then subtract this number from this number, because 32 divided by 4, you take 30, it'd be log base 5 of 32 divided by 4, basically, right?
Mm-hmm.
And you take this one minus that one, and you're going to get 2.1534 minus 0.8614. Do you agree with that?
Mm-hmm.
All right, take your calculator from me, please, and then go ahead and evaluate that for me, and let me know what the answer is going to be.
It's going to be negative 1.292.
Negative 1.2920.
Mm-hmm.
Alrighty, so negative 1.292. And that's our answer. Okay? So if I hit this, well, actually it should be, well, they have a, I guess they have a different circle on there, but yes, it should be the negative side, right? Mm-hmm. Okay, good. Any questions on that so far? Okay, outstanding. All right. Let's move on to another thing here. Actually, you don't have to worry about that particular problem. Where's the other one at? Okay. Writing equations. Alright. The logarithm of power is the product of the log and the exponent. So let's write that portion down as one of our little properties, or another rule. Okay. This is going to be the logarithm of a power. The log of a power is the product of the log and the exponent. The product of the log and the exponent. Okay? So, for any real number p and positive numbers m and b, as in boy, where b does not equal 1, we have log base b of m to the p, right?
Yep.
Equals should be p log base b m, right? Because we take the exponent, actually in this case, shifts down in front of the log. Just like it would do in exponentials that you guys learned about a while back in Algebra 1. Possibly the beginning of Algebra 2 or early stages of Algebra 2, you would have learned that particular situation. So I'm going to hit the button here. Let's look at one problem. Given that log base 5 of 6 is 1.1133, approximate the value of log base 5 of 216. So log base 5 of 6 is approximately, say, 1.1133. And then I'm looking for log base 5 is 216, right? All right, so tell me now, what would I do with that? What's the easiest way to do that problem that you think? If I'm looking at products and powers.
Can we break down 216?
Okay, we can break down 216, right? Into maybe, what is, if you divide it by 6 on your what is, if you do 6, how many times do you do 6? Do you do 6, like you multiply 6 together? How many times if you multiply 6 together do you get 216? You might want to try that out.
Yeah.
And see if that works first. How many times you get?
Oh, just 3 times.
Just 3 times? Okay, good. So log base 5 of 216 really equals log base 5 of 6 cubed. Now, at this point, I can move the 3 to the front. It's almost like when you're in line in school, right? You go to the front of the line and you always either be trying to cheat and cheat your friends, right? You went to the front of the line. So here it goes to the front of the line. And now we have 3 log base 5 of 6. All right, now, in order for us to calculate this, log base 5 of 6, we just discovered was 1.1133. So 3 times 1.1133 is approximately, or is equal to 3.33.3399. A lot of multiples of 3's going on there. So that would be our final answer. Does anybody have any questions on that? Or do you have any questions on that?
No.
It's pretty simple?
Yeah.
Okay. Good. So we will continue on that one at some other time. But those of you out there, thank you for watching the session. I will do some other sessions in the future, but I appreciate your time, and hopefully we'll be back. All right, peace.